second. Excellent. Okay, I'm going to go ahead and let you take it from here. I'm looking forward to this talk. It's one of the more interactive ones I think we were planning. So go ahead and take it away.
All right, thanks everybody. Hey, this is Cary Bryzcek from Jama Software. And when I was thinking about, putting together a presentation, I just didn't want to do a demo. Everybody's seen a demo of Jama, and I wanted to have something interactive where you guys could get something back or feel like you are contributing in some way. And so I came up with, hey, let's have a talk to talk about what are the gaps today in tools. What can we do? What are the needs that we as tools vendors aren't hearing about? So as I, looked at across the board, things that are that I see, big topics and themes with digital engineering and transformation. This really was a very relevant to talk about, especially since the domain of requirements management and engineering is, it's becoming more diverse from just the traditional document based approach. So it's sort of a point where it's a really valuable to talk about these kinds of things. And so what I've done is I reached out to Jama and Vitech and ZUKEN to get some experts to help answer some questions and engage in some discussion. So I'd like to let them introduce themselves. Jeremy, would you like to go first?
Yeah, I'd be happy to. Thanks, Cary. Hi, everyone. I'm Jeremy Johnson, product manager, vice president of product management here at Jama Software. Been with Jama now for just over 2 years. Spent previous 12 to almost maybe closer to 15 years in product management leadership roles in enterprise software. My background is more on the risk management and environmental health and safety side, so I'm a little bit newer to the requirements and PLM side, but happy to be with you here today.
Great. Enrique?
All right, so I am Enrique Krajmalnik, currently Chief Operating Officer at Vitech. Prior to this position at Vitech, I actually worked with Bob at ZUKEN in a business development role. And prior to that, some of you may recognize my name from a stint for about 6-7 years with No Magic / Dassault Systems. I was Chief Technology Officer for No Magic. And my background prior to that really comes from a combined background of mechanical engineering and IT services. Was involved in mid-size enterprise IT services. So that's kind of where I come from, and very excited to be here. Cary and I have had a lot of conversations around this, so happy to hopefully share some of the insight that we've been able to glean from our conversations.
Thanks, Enrique. Bob?
Hi, everyone. My name is Bob Potok. I'm Vice President of Marketing at ZUKEN. And don't let the marketing title alarm you. I'm an electrical engineer by training, and I've done detail design for most of my career, doing FPGA design, board design, device driver type software. So I've been on the product development side heavily in my career. And around mid-career, I switched to the electronic design automation industry, where then I switched to actually developing the tools that are used by detail design. So I'm coming at the whole digital engineering challenge from the detail design side. And the gap conversation is very relevant to what I work on a day-to-day basis at ZUKEN.
Awesome. Thanks, Bob. So I have a few questions to get us kicked off with. And one of the observations that I've made, and actually many customers of mine and prospective customers that come to Jama ask about is, hey, MBSE, it really seems like it's, very siloed and tool based. It's its own kind of discipline, but it's how do I connect it? They ask, how do I connect it upstream and downstream to the engineering teams. How do I facilitate traceability? So the question is, how are the tools, addressing sort of this broken value chain? Do one of you want to go first, or I'll pick Enrique to go first?
Sure. Yeah, that's great. I think this is a great place to start. Broken value chain. I think that's a great way of really highlighting the problem with the lack of digital continuity in many of our environments. We're not properly connecting, as this says, requirements to architecture, architecture to detailed design. We see all these nice pictures put out by, I'll use your term, marketing, Bob, by marketing organizations with these silos that are connected with these lines, but no one's defining what those lines really mean. So we're painting this picture for customers, but then the execution really isn't there. And customers are left, because these interfaces aren't properly defined, customers are left having to design these ad hoc processes to link data. And these are often done in a batch mode. They're disconnected, they're slow. Obviously, if they're done in this batch mode with traditional import exports, there's no traceability in what's going on with that. So it's really a challenge for organizations. So what can we do about that? Well, that's a really interesting question, because I think one of the challenges we have faced in trying to address this is that we've been focused on addressing this from a data-centric approach. And that's kind of what has left us, I think, in this process of exposing these import-export interfaces. But we haven't really looked at it from the process perspective. What is it that organizations are really doing to move from point A to point B in their design process, in their manufacturing process? And I think we need to start looking at that and seeing how we expose both data and tie tools together from a process perspective to begin to address this broken value chain. And I'll step back for a second just to see what comments Jeremy or Bob may have on that.
Yeah. Jeremy,
let me jump in and talk about that and continue what Enrique was saying. One thing that we've realized talking to a number of customers is that maintaining model relevance throughout the design process is really the challenge behind digital engineering. Everybody's on board with digital engineering. The idea of getting rid of documents and replacing it with a model-based process, everybody's on board. The challenge is that value chain gets broken. There is a big process gap when moving from systems engineering and the model construction to detailed design and the model implementation. That's where we see the big gap. And the challenge is keeping that model relevant throughout the entire design process. So how, when we get the detailed design, how do I stay connected to the model? If I can't fulfill a requirement, how do I communicate that back to the model? Those are the challenges that we've been working on. And again, coming at it from the detailed design perspective, we're looking at trying to put, and this is going back to the process that Enrique is referring to, we're trying to basically create a design envelope that we can extract from the model and hand over to detailed design. We think that's a good approach so that the detailed design team working on this design envelope can implement correctly. So it is a challenge. We're working on it here. And I think it's one of the roadblocks for broad adoption of digital engineering.
Mm-hmm. Jeremy, what about you?
Yeah, I think I would agree with Enrique and Bob for the most part. I think I would maybe be a little bit stronger on the answer in that I think MBSC today definitely tends to be isolated, and a lot of different pieces in the engineering processes seem to be isolated still, but it doesn't have to be. in today's age. There are definitely solutions out there to pull these pieces together. Mentioning linking data, and certainly that's only part of the equation, but it's certainly an important piece. And I would argue a little bit that the modeling component, the digital twin component, so whether it's 3D models or 2D modeling, with bringing that together with the digital thread of textural requirements and making sure that is, to Bob's point, those changes and that evolution is moving between those two in as close to real time as possible is super critical. And there are ways to do that out there in the world today. There are solutions that can bring that together, whether it's linking data, in some cases actually bringing in the interface of seeing models right next to the textural components, so that can be a very dynamic experience for people. I know we'll talk a little bit later about how we better enable process and things like that in this discussion, but there's a really significant growth in user experience when you can put both of those worlds together in real time, and really allow engineering world to really collaborate very deeply in those areas. So again, I think the big thing to me in this area is these things don't have to be siloed. There are definitely ways for bringing these disciplines together, bringing this data together out there in the marketplace today.
I have to agree with you on that, Jeremy. There are definitely technologies that have evolved over the years that the software vendors can use. I think part of the challenge speaks to the pedigree and the original software that was developed for many of these engineering disciplines. It was desktop software, right? It was built to address a specific design challenge. And as you know, it's very different to build that than to build a connected enterprise type application. And that's something that we as the vendors need to address.
Yeah, no, that's definitely fair. Absolutely.
Are there any comments or questions from the audience? All right.
This is Lou. Bob, you brought up a gap between the model representation of a system and the actual ability to build that system, to manufacture that. So I can have a model, but in the end, I have to have what I call design output specifications that I can hand to manufacturing to actually build someone. Were you referring to that gap?
That's exactly the gap that I was talking about, because here's an example. Let's say I'm modeling a vehicle, and a vehicle has 100 ECUs in it, electronic control units, which are basically PCB subsystems. I would have to take that model and somehow extract each of those ECUs in terms of what we refer to as a design envelope, and hand it to the implementation team for manufacturing. And one distinction I'll make is when I talk about the model, I'm referring to as the product model, as opposed to 2D, 3D digital twin models. They're very different in our world. So yes, that's exactly what I'm referring to. The ability to take the product model, partition it into work assignments, deploy it so that it can be implemented. And then you have to realize that those 100 ECUs have to come back together again to actually implement the vehicle. And one thing we've joked about in talking with customers and after we acquired Vitech and working with Vitech, that in many cases, systems engineering seems to be on an island. And somehow we have to connect systems engineering with the whole product life cycle, because in many cases, and I've heard this from a customer, where they've constructed a product model and they took 4 to 6 weeks to essentially convert the model into documents to hand to detailed design. And at that point, the model got left behind and you're disconnected from the model, and you lose a lot of the benefits of digital engineering. So that was exactly what I was talking about. So hopefully that's resonating with you as well.
Yeah, and one of the gaps that it seems like is in the model world, you know, the focus a lot of times is on the functionality, performance, and so on. But when we transfer across into the physical world, then we have chemistry and physics and thermodynamics and biology that needs to be considered in actual manufacturing and operation of the system. And how well do the models really address the real physical world?
That's so funny you bring that up, because I just was having a conversation about that this morning, where the model requirements are essentially at the product model level, but from a detailed design engineer who's worried about, you know, airflow, cross coupling across signals or cross coupling across wires, that's a different domain. And that's the expertise of the detailed design team. And those requirements are more design constraints versus product requirements. And there's that separation. So that's why we refer to as kind of moving a design envelope to detailed design, because we don't want to get into too much detail in the product model in terms of that level of design and analysis. If I'm doing signal integrity and power integrity analysis at the detailed design level, that's my expertise as a detailed design engineer, not really up into the product model specification.
Thank you.
You bet. Good question.
All right. Thanks, everybody. Let's check out another question. So we've got this one sort of extends out into the ecosystem. So organizations today have not only internal challenges connecting digital threads, but communicating that digital thread and the requirements across to their customers and or to their subcontractors or to across their supply chain. So how are tools today addressing this type of need? And, you know, maybe what are some of the gaps still yet to be closed for this? Enrique, you want to kick us off again?
Sure. So this idea of an open ecosystem is really important. It's really important for several reasons. Obviously, we are trying to connect disparate groups with disparate tools in an organization, and we need to have some continuity of data, of process, of workflow across those. And that ecosystem, we have to realize, is probably larger than what we see in our immediate interfaces that connect to us, right? So each discipline has, or each group has something that's likely upstream and downstream, but this ecosystem gets bigger than that. It gets into your supply chain, it gets into your manufacturing, it gets into, could even get directly into customer logistics and sales efforts. So we really have to look at a more holistic view of how we are building our tools, building our interfaces, and exposing data for use across many different aspects of that product lifecycle. That's something that we are hearing more and more. Organizations want to be able to understand their, not just their product design process, they want to be able to understand and connect their manufacturing process, their sales process. So these ecosystems are really, really important. And these ecosystems are typically driven by some sort of standard. Jeremy started talking earlier about, you know, there are technologies that we can use. And I assume some of the technologies you're talking about, Jeremy, are standard types of APIs that can be exposed. There are data formats that are standard that can be exposed. And we need to do a better job of both defining those and implementing those so that we can connect these ecosystems and these products to build an ecosystem in a much more holistic way.
Mhm.
Yeah,
Jeremy.
I think that's exactly right. I think we're sort of entering, or probably well into, this phase of or this environment of hyper collaboration at this point. Certainly, a lot of people would point to the last couple years and the way work has evolved, but really we were heading down in this direction anyway. That just accelerated things with global teams and global organizations, and Enrique, as you mentioned, with global supply chain and the complexity that arises there. And I agree. There's standards out there, OSLC and REC-IF, things that are, I would say, are unevenly adopted throughout the industry. So they're still only part of the solution. So I think we definitely have, as an organization, or excuse me, as an industry, and as vendors in this industry, I definitely think we have a ways to go in this regard. But there are pieces, certainly those standards that we mentioned, easier import and export of data that can communicate within the supply chain. I think more and more we're starting to see our customers start to bring their third-party partners directly into their processes and directly into, in our world, it's around things like requirement reviews and things like that, where we now have, and there are similar things in the industry. This isn't unique to us per se, but where we have the permission structure, we have the licensing structure, we have the ability now that people can come directly in and collaborate. And there's enough security and data segmentation that we can protect IP, but still bring people into the process. And so I think you're going to start seeing that more and more in the industry, where people are getting brought in directly into the process and not just relying on certain pieces of communication. And we're certainly getting to the point that we're evolving away from things like email, things like that to communicate. Even Slack, I think at some point it's made things much easier. You can start bringing separate companies into your Slack environment. You can collaborate that way, but it doesn't have the level of permanence that a more bespoke solution, a more dedicated part of your workflow does. Audit trail and the level of rigor that we need to capture in those types of discussions. So things like Slack have certainly accelerated and opened up opportunity to collaborate with people across and outside of your company. But it's in some ways almost too fast, or at least it doesn't have the permanence. So I think we definitely have some gaps in large part that we need to continue to work through as an industry. But I do think we are embarking on the point where we are starting to see more people bringing their partners directly into their process, directly into their tools. And I think that's only going to continue.
Yeah, sure. I think there was, oh, go ahead.
Oh, go ahead, Cary.
Oh, go ahead, Bob. Sorry, stepped on you.
No worries. I was just going to comment. I think the ecosystem in our world is becoming more and more important, just because product complexity is going through the roof, and product complexity is one of the drivers of digital engineering and model-based design, going back to that kind of single source of truth. So the ecosystem is becoming really important, but how you communicate with that ecosystem has been kind of changing over time. We're finding historically there would be a export-import function, and that export-import is becoming obsolete. I mean, I think the operative word today is data exposure, and you've heard Enrique say that over and over again. Expose the data, not necessarily export-import the data. So if I can expose that data across my ecosystem, I'm going to have much more reliable communication, much more efficient access to important data. So a couple things, for example, in our world, we're using APIs more and more to communicate with the supply chain. So when we look at component information, for instance, our management systems connect right to the supply chain vendors and they pull data immediately. There's no export import function. Another important piece are standards, cross-discipline standards. So for instance, in our world, we work, thinking about printed circuit boards and thinking about wire harness. We use IPC 2581 standard to actually move connector information from the printed circuit board world into the wire harness world. But that IPC 2581 is also handed over to the manufacturing floor, and that's how they fabricate the printed circuit boards. So the usage of standards and APIs is really allowing data to be exposed and getting away from that export import step that just creates so many disconnects and so many errors in the design process.
If we rely on import export, traceability goes back to that initial statement you had, weak at best, right? You have to have some sort of identifier in your import export process to link the two sides of that data. APIs are great, but we still have a challenge with APIs. And we can go back and look at a standard outside of our engineering world, in the IT world, a standard called Simple Network Management Protocol. Simple, right? It was there to allow network monitoring applications to collect data and monitor networking devices regardless of the vendor. And we ran into a problem with that. Each vendor, the standard was defined loosely enough that each vendor implemented it their own way. And it became very difficult to have a standard implementation. We kind of see the same thing with OSLC, right, Jeremy? And this is something that vendors don't like to say, but I'm going to say it. I think to some extent, we need more strictly defined standards. Without more strictly defined standards, we're going to continue to run into that same challenge. And vendors don't like the strictness of those standards because we often feel that limits our ability to innovate and differentiate. But I think without that, we limit the ability of our customers to innovate. So I think it's a very fine line we need to address as software vendors. But more specificity, more constrained standards will help in that.
Yeah, I agree. I think, Enrique, that's exactly why you see things like OSLC being somewhat unevenly applied in the industry is because of that. You get a lot of flavoring out there, and it's hard to realize the benefit or the return on investment when you have to specialize for different tools and things like that because of the different flavors that you see out there. So I think that's a very legitimate point.
Lou Wheatcraft, you had something to share?
Yeah, can y'all see the chart?
Yep.
So this is a chart that was in Integrated Data's Foundation System Engineering that we put out. And actually one of the presenters yesterday, Tony Williams, referred to this chart. But it seems like for this question, that's kind of a key thing. This is a vision that we put into this document, that on the top you have separate applications that are developing these products, a lot of times maybe within silos. And the vision is all that representing data goes into some kind of integrated, federated, shareable sets of data. And on the bottom, you still have a lot of these different artifacts. They may be still being developed in different applications, but it's set up so that they can share the data between each other. And so if I'm, like in the earlier presentation, if I make a change in the requirement that's managed in a tool like Jama, can that change be reflected automatically in state models? Or if if I have a requirement in the model and I change it, you know, how easy is that to go back and be reflected in the requirements in Jama or something like that. So this is kind of a vision that we had. And I was just wondering, you know, from a gap standpoint, how close are we to this vision?
Not very. Not very, to be honest. I think it's a shared vision that most of the vendors have. We want to be able to support that type of environment. But there are a lot of complexities associated with this. You have different schemas, different meta models. How do you reconcile that? You know, a lot of these products aren't built on messaging buses or messaging infrastructures where, you know, these events can trigger activities. I totally agree with what you're saying there. You make a requirement change, you don't just want to see it reflected, you know, in the downstream tools that are connected to it in the downstream designs. You want to have an understanding of the entire impact of that, right? How does it affect the design? How does it affect other requirements, other design constraints? You know, there's this cascading effect.
Oh, absolutely.
Right.
And that's one of the visions. That's the kind of a vision of this whole thing, is that we can really address the impacts of changes across the life cycle.
Yep. And the thing is that this all begins with traceability. This all begins with understanding all of the relationships and connections amongst the data. Once we have that established, we can start building additional functionality on top of that. But we still have to address that underlying challenge of different schemas, different meta models, different API implementations. One thing that potentially could address some of this is if we, as an engineering community, could decide on some sort of a standard meta model that is at a high enough level of abstraction, but still semantically meaningful and rich, that we could use to ground data from different applications, and then understand, you know, have that as that underlying mechanism for understanding what type of data we have and what it means to us in our engineering domain. So it's a big challenge, and it's a great vision. But I saw the look on Bob's face when you asked how far we were, and yeah, not that close.
No, I think we've got a long way to go there. There are mitigation factors or things we could do, and because one of my big concerns, you know, I don't think there is a unifying model. I mean, I appreciate the data-centric approach, but as Enrique said, it's very challenging because there are so many models in the product development system. So the printed circuit board model is very different than the product model. And the models are built for specific purposes. And, you know, an example of real world today is if you want to version control a printed circuit board model, you check that model into a PLM system, but it goes in as a blob, a binary large object, because the schemas are so different that they're not compatible. But you manage it through checking in a blob. So we've got a long way to go to try to build that unifying model that sits at the top. But for the time being, I think there are checks and balances you can put into the process and have more of a process-centric view, where a couple things can happen. Number one, we can avoid model implementation divergence, which is one of the big fears when you're building a complex product, that the model and the implementation diverge and the ultimate result of the product doesn't quite match the model. We want to stop that. We want to put checks and balances in, or verification events that ensure synchronicity between the model and the implementation. So just without rambling on, I would say there are process checks that we can achieve to ensure that consistency, but a unifying model, I think, is a ways off.
Thank you.
All right. Hey, we've got a couple more questions from the audience. John and then Craig. Whoops. John Clark asks regarding this particular theme: is the problem with a broken value chain related to the problem that MBSE does not model the upstream or downstream engineering?
I'll try to address that. I don't think it's because we don't model the upstream or downstream engineering. I think it goes back to part of what Bob was saying right now, that we're not properly transitioning from that architecture to that detailed design. I think we're doing a good job, at least I've seen many customers doing a good job of doing their architecture design. And there is enough detail in the architectural design to prime the detail design, to begin that process, to provide that specification needed to start the detailed design. I think the challenge is that, as Bob mentioned, to transition, many organizations still have to implement some sort of ad hoc process, and they go back from a model to some sort of document instead of keeping the model connected, keeping the model relevant. And as important is keeping the model up to date, right? We mentioned that there are physics and multi-physics involved in these product designs. And, you know, as those things are reviewed, they could potentially have an impact on the architecture and the model. And we have to be able to keep that connected and synchronized and relevant throughout the process. So that's what I think is a more direct cause of this broken value chain, that you either have to, you know, you're basically manually recreating a lot of this when you transition, in a nutshell.
That's it.
Craig, you have a question. Your hand is raised.
Yes, going back to the diagram for the integrated data as a foundation for SC, and Bob's comments about the processes involved. It seems that there is enterprise level processes for getting the information across these barriers, so that even if you don't have real-time data feeds between these systems, the enterprise itself has processes that need to be documented and managed for making those connections where it's not yet automated. Isn't that the case?
Yes. So when we talk about digital engineering, so I look at, there's systems engineering where the model is constructed, and there's detailed design where the model is implemented. And detailed design consists of mechanical, software, electrical, and electronic. So they're very two different worlds, I would say, that we have to bring together through processes. Now, when we talk about the enterprise level, I immediately go to the PLM system, and the PLM system does an excellent job in connecting and managing detailed design and connecting it to manufacturing. It does an excellent job. When we bring in the digital engineering story, when we want to now have a completely model-based process development system, so detailed design really depends on the model in directing its implementation efforts. That's where we need the new process checks, the new additions, if you will, so that we almost have a new layer of the digital thread for communication, for data management, for verification. So everything works together. So I think it's this new layer here that we're talking about.
You're talking about the between the model and the detailed design, correct?
Correct. Yes, all the way through into manufacturing. Exactly.
But
So that,
I think I'm talking about something a little different. I'm talking about how the model and the detailed design fit within the context of the business and how operations works in the business more at a higher level and not between the model and detailed design.
oh, I see. Okay. So I don't want to, Enrique or Jeremy, do you have a comment on that, or I can jump in too?
Please
No
feel free.
comment? Okay. So from a detailed design perspective, in many ways, we've kind of solved the enterprise issues because we have PLM systems that handle manufacturing, we have supply chain integration and so forth. So from a business perspective, we're pretty good at that. Now, bringing in systems engineering is a new concept to many companies. It's kind of a new area in bringing in model-based. And having this all blend together at the enterprise system and business systems, I think those are the challenges that I would agree with you, Craig. I don't think they're totally solved right now, but at some level, just like PLM sits across all the top of the detailed design disciplines of mechanical, software, electrical, electronic, I think we need another layer that sits on top of the model and the detailed design manufacturing. And also we're starting to get into field performance and measuring field performance and bringing that back all the way to the model. So we need a level that manages the product lifecycle from model to field performance of your product. That's the piece at that enterprise level. I think that might be the next generation. I don't know if you want to call it PLM or what, but that's the piece that I think we have a lot of work to do in that area.
Thank you.
Some great comments going on. Let's talk about this a little bit aside, sidetracked. There's a lot of people out there that are sort of criticizing, the rigidity of tools. That some of the tools out there are just not keeping up with how engineers actually need to do their work today, this is resulting in a lot of missed opportunity. How are tools today addressing poor UI and user interface and just adoption in general? Jeremy, you want to kick us off?
Yeah, I'd be happy to. Yeah, so we're actually, I think, more and more starting to see across enterprise software just a fundamental investment in user experience. So my very short answer is you have to invest in it. It's something that's been lacking in the enterprise space in general. In this space in particular, the PLM space broadly, it's certainly been something that's lagged. It's been more focused on depth and breadth and feature expansion and some of those things, and that brings a lot of negative artifacts over time. And I think Enrique, you even pointed to this very early in your comments, and I think it's certainly true that we've got some age in some of the applications in this space, but it also is on some level accumulated feature expansion and that breadth and depth. And when you add things without very thoughtful design, it can be a mess, to be perfectly frank. And there's a balance to be had between feature depth and adding that richness and that complexity to manage the complexity that our customers and all of you deal with on a day-to-day basis, but doing that in a much more thoughtful way. And it's important for organizations and for folks that are looking at tools out there. User experience is not just the visual component, right? That's the thing that I think is most important for for organizations to understand. The biggest part is the interaction design, the human factors, looking at business processes, how people are actually executing work, individual motivations. All of those components are super critical. And I think you're starting to see now, at least with some organizations in this space, where user experience is actually leading the design side. User experience is leading the implementation, the logic development, the back-end development. It's not the feature and the need and how do we implement this from a technical side and then prettying it up as much as possible. Flipping that equation is definitely critical. The last thing I would say is we're also starting to see more meeting users where they're at today. And so that's part of this discussion with bringing these different pieces, bringing the data together. I think anytime you get into the mode where you're looking at a broad monolithic implementation of a single tool and forcing certain work streams to use a tool that just is not right for purpose, you're asking for trouble from an adoption standpoint, from an engagement standpoint. And so when you're able to bring together these bespoke, best-in-class, purpose-built tools for certain applications, that's also a way to continue to ensure adoption and streamlining efficiency, rather than taking a more heavy-handed approach in adoption and rollout. So I think those are some big things to keep in mind.
Any comments from Bob or Enrique?
Actually, I do have a comment because something related to this came up the other day in one of our discussions, in that we seem to be making a lot of our tools more complicated than they need to be. And what I mean by that is we give people 10 ways to do the same thing in the tool, where they could have just given them 1 or 2 ways to do it. And by giving them 10 ways, it makes the tool so much more complicated to use and to learn. And we have to really think about reducing, I guess, the use cases or the options or something to simplify the tool usage. Because we're finding that people are becoming less, in some cases, they're becoming very specialized, but in other cases, they're becoming less specialized. So for instance, printed circuit board tools are becoming very commoditized today. So let's make them simple, let's make them easy to use, because lots of times there are not printed circuit board implementation specialists anymore. Electrical engineers do the whole thing. So we have to think about how the tools are being used in what context, but that's one of the challenges that we see. And I saw a recent study the other day too, just happened to look at it, that it said 50% of the features in a tool are rarely or never used. And I see Jeremy nodding his head right there. So in many cases, I think we're kind of creating our own problems by overcomplicating the tools in many respects. Jeremy, you have a comment?
Yeah, no, I think you're exactly right. I think it is a delicate balance. I'll speak very candidly from my perspective. We want to do as much that our customers ask us to do. We want to deliver enhancements. We want to respond to things, but it does have a negative artifact. It does have negative repercussions in some cases. And so I think about being very thoughtful in how we implement those. So it's definitely something where we need to take on a level of balance in our implementation and things like that. But I do think it's something that the customers need to think through about that balance of depth and richness versus user experience, ease of onboarding. There's certainly more that us on the vendor side, on the application developer side, can do better. I will absolutely acknowledge that, to make things easier, to bring in consumer-driven design patterns, all of those kinds of things we can do. But there's also a balance. And I do think some of that complexity, all of the features that come in, it does inhibit time to value and onboarding and adoption and things like that in certain cases. So it's certainly a delicate balance.
All right. We got another question out here. So the mindset, workflow, you know, we read a lot of blogs and marketing materials out there that talk about the, you know, the digital thread and the need for data-centric tools and approaches. And it always seems to be about the data and the data. But what we don't hear about is, you know, how can the tools enable the engineers to do the process of engineering itself, to do the requirements engineering or do the design engineering itself? How are tools enabling a more process-centric paradigm is the question. Bob, you want to kick us off?
Sure. So this is a great question because I'm all about process, and Enrique knows Enrique knows that. I would say a lot of improving processes are, I'm going to go back to two things again. One I mentioned earlier is I am all about getting things moving towards standards and APIs, because that just moves the process along, moving away from import-export functions. I think that's an important piece. But in the context of digital engineering, I'm going to add another layer there, where process, going back to the model and this notion of verification events are really important, because when you look at the engineering mindset today in the detailed world, for the most part, everybody thinks about documents. And we have to change that mindset to think about models, because there are a huge amount of benefit when we look at model-based design versus document-based design. But getting the model mindset into detailed design is the challenge. And the workflow, as I said, there are things we could put into the workflow, and the biggest one I like is verification events. And what I mean about verification events is, so let's just say the model is ready for implementation. You break up the model in different work assignments. Like I mentioned earlier, I've got 100 ECUs in the car. So I'm going to have maybe 15 different design teams working on these 100 ECUs. And now they're going to do their initial check against the model. Their first verification event is the architecture. I'm going to do an architecture verification so that I can have a pretty high confidence level that I can hit the cost target, the weight target, the functionality target, the dimensional target. So I can do these. And at that verification gate, I can feed back to the model that says, okay, ECU number 1 is highly confident that they can meet all the requirements associated with ECU number 1. That brings in a nice workflow with all these milestones that ensures consistency between the product and the implementation. So that's just an example. Another big one for me is what I refer to as digital conversations, which goes back to the traceability, which everyone's been talking about. Having a digital conversation backbone where discussions are not done through email, discussions are done within the context of the data. So I might have a conversation around a requirement, and I know Jama is really good at that. The ability to track conversations to a requirement so that if a requirement is altered, you can answer the question, how did we get here, right? Answering the question, how do we get here, is so important, and that's what traceability does for us. So that's just a couple of examples how I look at the engineering mindset and the workflow that has to change when you get into a digital engineering world.
I think part of it also goes back to what we talked about with ecosystem, right? Software vendors, I think, have done a good job in general of understanding how customers want to use their tools in the context of their tool. What we haven't done a good job of is understanding how customers want to use the tool or need to use the tool across the gap to another tool. And there are both, I think vendors are starting to do a better job of understanding our customers' processes. We're doing a better job of teaching process where applicable to customers where process may not exist. But at the same time, there are also technologies that are contributing to that. There are service-oriented architectures and microservices that can be used to expose data in a process-centric way so that we can fill those gaps in a better way for our customers. And I think that's when we start to look at the big picture, we as vendors will build tools that will contribute to enabling this paradigm shift.
Yeah, I think just a couple things that I might add. One of the things that I think we're seeing more and more is integrating kind of industry specific content and workflows. So specific configuration, report types, built-in guidance with the tool. It speaks to some of the user experience and adoption that we talked about previously, but as far as getting more process centric, I think distilling some of these down to what's a best practice for a particular industry. I would agree with Enrique there's some growth to go to look at that beyond the context that we might be working it in as a specific vendor. But that's something that certainly kind of aids this process-centric flow, allows organizations to focus on their core business rather than trying to figure out the process of requirement authoring and things like that in our world. Another thing from a technology standpoint that I would mention is we're starting to see, I would say still fairly early, starting to see machine learning and those steps towards AI start to come into the picture here. So thinking about there are some third-party tools, there are some things that we're doing internally around giving real-time guidance around requirement authoring, for example, that's built on machine learning and natural language processing. I'll give a plug and shout out to Mav and Lou for their help in the work that we've been doing. But that's something too from a process standpoint. And to me, again, I think it's allowing organizations to and the engineering community to really focus on their work, which is developing great products. The companies that we work with are not requirements authoring companies. That's not their core business. So some of those things that vendors can continue to inject from a pure technology standpoint to aid in best practice and things, I think will really be a fundamental component to help engineers as they hone their processes.
There was a question from the floor. Is this the role of business modeling tools and process?
I think those tools can be used to understand both, let's use the language we're all comfortable with, right? The as is and the to be. But it's the software vendors that are responsible for providing a framework for implementing that. And that's where there's a big gap today. If we don't provide that proper framework, I don't think it really matters what we model in terms of process. If we can't implement it, it doesn't matter. And what ends up happening is that the implementation is left entirely to the organization. And that means that the depth and scope of the implementation is entirely based on the skills in the organization. So we see many varying levels of integration. Larger companies with large IT teams and engineering teams tend to do a better job of this. But if part of our goal as software vendors could be to help democratize the use of these technologies, I think we need to do a better job.
Hey, well, thank you, gentlemen. We've reached kind of our pinnacle on time limit. I want to thank you so much for coming to bring your expertise in this discussion, and we can hand it back over to you, Tammy.
Thank you guys. Thank you all so much. I really appreciate it. That was
You're
the only one of our talks these last 2 days that was a panel discussion. And I really think that format was exceptional. I really appreciate you all bringing that to us today. I'm going to go ahead and pause the recording.